Download this code and get free GPT-4o from codegive.com, link in the description below. ## aggregation relationship in Java. Aggregation is a special type of association that represents a relationship between two classes. In aggregation, one class, the whole, contains references to one or more objects of another class, the parts. The key feature of aggregation is that the life cycle of the contained objects does not depend on the life cycle of the container object. ## characteristics of aggregation. 1 has a relationship, indicates a whole-part relationship. For example, a library has many books. 2 independence of life cycles, the lifetime of the contained object does not depend on the container. If the container is destroyed, the contained objects can still exist independently. 3 shared ownership, the contained objects can be shared by multiple containers. ### example of aggregation in Java. Let's consider an example of a library and book classes to demonstrate the aggregation relationship. ###. Step 1, create the book class. ###. Step 2, create the library class. ###. Step 3, using the classes. Now, let's create a main class to demonstrate how to use the library and book classes together. ###. Explanation of the code. Book class represents the individual books. It has attributes for the title and author, along with appropriate constructors and methods. Library class represents a library that can contain multiple books. It has a list of book objects, which signifies aggregation. The addBook method allows adding books to the library, and DisplayBooks method lists all the books. Main class, this is where we create instances of book and library, add books to the library, and display the list of books. ###. Output. When you run the main class, you will get the following output. ###. Conclusion. In this tutorial, we explored the concept of aggregation in Java using a practical example of a library and book. We demonstrated how to create classes that exhibit an aggregation relationship and how to manage the contained objects independently of their container. This understanding is crucial for designing well-structured object-oriented systems.